This recording is for Chapter 4, Section 2, Graphs of Rational Functions. Please find that section in your book and open up your notebook and we'll get this one going. First thing, I made up a list of steps that we need to take in order to be able to graph some functions. It's the same table that's found in your book for Section 4.2, but I turned it into a couple of extra steps and a couple of, well, not extra steps, but a little bit maybe more understandable wording, I hope. So step number one, once in a while our functions are going to have numerator and denominator functions that can be reduced and simplified with each other. So we will be looking for that and at that. Number two, find the y-intercept and plot it by finding f of 0. So in other words, we plug 0 in for x and find the value, and that gives us our y-intercept. We've done a lot of that. Step three, find the zeros of the numerator. These are the x-intercepts. 4, find the zeros of the denominator. Those, remember, are the vertical asymptotes. Number 5, find and sketch the horizontal asymptote if it exists. If you forget the rules that are associated with the degrees of the functions, look back to page 314 so you can figure out whether or not you have a horizontal. Number 6, plot at least one point before and after each intercept and asymptote so you can get a better idea of how the curve is going to go. Then number 7, connect all those dots and points plotted with smooth curves. All right, let's take a look at our first checkpoint problem. Sketch the graph of f of x equals 3 over x minus 2 and state the domain. All right, first of all, let's take a look at that domain. Essentially, every value is going to work in this function except 2. We can't let x be a 2 or our function will be undefined. Our y-intercept. Let's go ahead and plug 0 in for x, and we end up getting negative 3/2. So our y-intercept is the point 0, negative 3/2. Our x-intercept. If we plug 0 in for y, multiply both sides by x minus 2, we're going to get 0 is equal to 3. Well, that is not true. So we actually have no x-intercept. Let's take a look at vertical asymptotes. Okay, since our domain says that we can't have x equals to 2, that line x equal to is our vertical asymptote. Horizontal asymptote. That one tells us to check and compare the degrees. Well, the degree of the top function, our numerator function, is 0. And then the degree of our bottom function is 1. So when the degree of the top function is less than the degree of the bottom function, then we're going to have y equals 0 be our horizontal asymptote. And again, if you have to, look back on page 314 for that rule. So let's get a couple of these things on there. Vertical asymptote is 3. Our curve is not going to cross, not 3, 2. Not going to cross x equals 2 line. Our horizontal asymptote is y equals 0, or the x-axis. We know our intercepts. 0, negative 3/2 is an intercept. We did not have an x-intercept, so the next thing that we're going to do is we're going to choose a few points and work our way toward 2 from both the left and to the right. So for this first one, I just picked a few points. I picked 1 and 1.9, and I picked 3 and 2.1. You can do more. You certainly can do much more, but I think that many will give us an idea. So if we plug 1 in, we're going to get negative 3. If we plug 1.9 in, we're going to get negative 30. Plugging 3 in, we get 3. Plugging 2.1 in, we get 30. So let's plot these points. 1, -3 is here. 1.9, -30 would way down off of our graph, so I think that gives us the idea that this curve is going to stay right in here. Then we have 3, 3, and we have 2.1 and 30. So again, it's going to go very high, very fast, getting into that 2 line, and it will ease down here to our other asymptote like that. Let's take a look at another checkpoint problem. This is checkpoint number 2 at the bottom of page 321. Same kind of thing. We're going to sketch the graph of c of x this time. Take a look at your numerator function and your denominator function. Can you factor them? Can you simplify anything? Again, for this one, the answer is no. So we're going to go on and figure out our things here. Let's start by finding that y-intercept. Putting 0 in for x, we're going to get 3 plus 2 times 0 over 1 plus 0, or 3. So when we put in 0, we get out 3. The x-intercept, 0 equals, and I'm only looking at the numerator here, equals 3 plus 2x. So move the 3 over. I get -3/2 for x. So -3/2 and 0 is my x-intercept. Vertical asymptote. Okay, vertical asymptote is where is the denominator undefined? Okay, when x is equal to -1, it's undefined, so x equals -1 is the line of the asymptote. Horizontal asymptote. Look at the degrees of your functions. The top function or the numerator function has degree 1. Bottom one also has degree 1. So what we need to do there, where the degrees are the same, we let y equal to the ratio of the lead coefficients. Well, our lead coefficient on the numerator function is 2, and the lead coefficient of our denominator function is 1. So y equals 2 ends up being our horizontal asymptote line. So let's go ahead and put these onto our graph. Vertical one is the line x equals -1. Horizontal asymptote, y equals 2. Now we can graph our intercepts, since we already found a couple of points. We have the point 0,3, and we also have the point -3/2, 0. Now we need a few more. Let's pick, we'll go with a -3, -2, 1, and 3. Plugging them in, you will end up with 3/2, 1, 5/2, and 9/4. So let's go ahead and graph those. At -3, we have 3/2. At -2, we have 1. So we can see how that curve is going to flow. There we go. Then we have 1, 2.5. We have 3 with 2 1/4. Should be right about there. So it looks like that curve up there, again, can't cross those asymptote lines. We know it's going to have to bend and come around there. Third one. Same thing. We're going to sketch another one. This one, the numerator function is 3x, and the denominator function is x squared plus x minus 2, which factors. Let's go ahead and factor that apart and take a look at it. So we get x plus 2 and x minus 1. So when we're taking a look at this one, the y-intercept, we still find that the same way. So let's go ahead and give that one a start. Put your zeros in. And we're going to get 0 over negative 2, which is 0. So our y-intercept is 0, 0. X-intercept. So we're just looking at 3x. So dividing both sides by 3, we get 0 equals x. That intercept also ends up being 0, 0. Now, vertical asymptotes. Where is our function undefined? What would be a 0 for our denominator? Well, we have two of them this time. We have x equals negative 2, and we also have x equals 2, negative 2, sorry, and x equals 1. Okay, those are the two zeros for our denominator function. Horizontal function, or horizontal asymptote, the degrees of this one. With this one, the top function has a degree of 1. The denominator function has a degree of 2. When the top has a lesser or a lower degree than the bottom, we end up with y equals 0 as our asymptote. Again, that's back on page 314 if you need to look back. All right, so let's get these lines and these intercepts on here. Both the y-intercept and the x-intercept are the origin. Then we had two vertical asymptotes, x equals 1 and also x equals negative 2. Okay, now we have a horizontal asymptote as well of y equals 0. All right, so we have a bunch of lines that we cannot cross. And we do have an intercept of 0, 0 in the center. So let's find us some points. If we go with negative 3, negative 1, maybe 2, 3, and make our table with them, let's see what happens. If you plug in a negative 3, work that through, you're going to get negative 9/4. If we put in a negative 1, we're going to have 3/2. A 2 gives us 3/2. And 3 gives us 9/10, so not quite 1. All right, so let's plot a few more points. Negative 3 and negative 2 and 1/4. Right about here. Negative 1 and 3/2. So at negative 1, 1.5. We also have a 2 with a 1.5. And we have 3 with almost 1. All right, so with this one, we got a couple of different sections going on. We're going to have this curve, and this curves are the ones that are kind of easy to figure out where they might be. Now, the inside there, you've got 2 points. We've got the origin, and we have that one that we have in there. We know this isn't linear, so inside our thing here, we still have to curve, and we still have to not hit those asymptotes. So it's going to do one of these numbers and skinny through there on the intercept. And another one. Checkpoint number 4 at the bottom, page 322. Same steps. Okay, we're just adding a little bit more to the kind of function that we're looking at each time. So our f of x this time, our numerator function and denominator function can be factored. So let's go ahead and do that and take a look at them. Okay? So keep in mind here, we have a number of things that still affect our domain. So I'm going to go ahead and write numbers that we have to avoid in our domain. We have to avoid 3, and we have to avoid -2. These cannot be x values. All right, anything else can work. So keep this domain thing in the back of your mind. Now, take a look at our factored function. We can do some reducing this time. So we're simply left with x minus 2 on top and x minus 3 underneath. So let's go ahead now and find our intercepts. If we put 0 in for x, we're going to get -4 over -6, or 2/3. So 0, 2/3 is the y-intercept. X-intercept, we only look at the numerator, remember, and we only have one piece left up there to look at because x cannot equal -2. So we're going to disregard the factor that has the -2, and we're going to look at the x minus 2 one alone. So when x is 2, y will be 0. We have our one intercept there. And again, the reason that we throw out the other one is because it does not fit in our domain. -2 was a number that was thrown out. All right, so our vertical asymptote. After we did our reducing, look over there and we have one value that's going to make our denominator undefined still. So at 3, we end up with a 0, so x equals 3 is that asymptote line. For horizontal, we have equal degrees again. We have x squared on the top and we have x squared on the bottom, so they both have degree of 2. So we take that lead coefficient and we end up with our y equals 1 horizontal asymptote. All right, so let's start graphing a couple of these things. So our vertical asymptote is y or x equals 3. Horizontal, y equals 1. We have a y-intercept of 0 and 2/3. We have an x-intercept of 2, 0. Now we need some more values. So let's go ahead. I'm just going to pick, we'll go with a few here. We got -7, -5, -1, 1, 4, 5. Again, you can pick other numbers if you want to. We just need to get an idea where this curve is going to go. Plugging in -7 and solving it through, you're going to end up with 9/10. Putting -5 in, 7/8. Putting -1 in, 3/4. Yes, I know you're getting a lot of fractions. You'll be fine. Putting a 1 in, we get 1/2. Putting 4 in, 2. And putting 5 in, 3/2. Let's plot those points. Now, there's not a whole lot of difference between 9/10, 7/8, 3/4, and 1/2, but notice they are going down a little bit. Okay, so when you're graphing these, try to make it look like that. So at -7, we're awfully close to the 1 line, and we go to -5, we're just a little bit further away, and at -1, we're just a little bit further away. And then, of course, we know that at 0, we're at 2/3, and at 2, we're at 0. So you can see then how our curve is going to really hug the 1 line for a while and then start heading down our vertical asymptote. All right, now on the other side we had 4 and 2 and 5 with 1.5. So again, we can see the tendency of this curve as well. All right, next one. If the degree of the numerator is exactly 1 more than the degree of the denominator, then there will be a slant asymptote. So this doesn't go with all of the things that relate to that number 3 on page 314, but this is one thing to consider if the numerator has a higher degree than the denominator. If it's exactly 1 more, then we can find what's called a slant asymptote, and this is how. To find this, you're going to use division. Okay, use long division to actually divide the two functions with each other. When you get done dividing, you're going to have a factor part, and you're probably going to end up with a remainder possibly. Well, you can kind of ignore the remainder. It's the factor part that is going to be the equation of your slant asymptote. So for example, look on the slide here. I'm telling you that a division resulted in the answer x minus 5 plus 4 over x plus 9. Okay, so whatever the two functions were, this was the answer when we did long division. The factor part of it is the x minus 5. So the equation of my slant line is y equals x minus 5. Let's work with this one. All right, looking at our numerator function and our denominator function, there is nothing that reduces or cancels out. So let's go ahead and find some intercepts. Well, if we plug 0 in for x in this case, notice how we end up with a 0 in a denominator. So the y-intercept is undefined. For the x-intercept, taking 0 and setting it equal to the numerator, we're going to get negative 1 equals 3x squared. Divide by 3, we get negative 1/3 equals x squared. Now if we take the square root of both sides, we're going to end up taking the square root of a negative number, which again is undefined. So there isn't an x-intercept either. So let's go on and try to find a vertical asymptote. There is one number that will make our denominator undefined, and that is 0. So x equals 0 is our vertical asymptote. The horizontal asymptote, if we run the check horizontal, if we run the check on this one, notice that the degree of your top function is bigger than the degree of your bottom. Okay, so there is no horizontal asymptote. But if you remember our last slide, the top degree is 2 and the bottom degree is 1, and that differs by exactly 1. So we're going to be able to find a slant asymptote. Remember from the previous slide, we find that by doing the division of our two functions. So we're going to go ahead and divide. So 3x, it goes in and leaves us with 1. So our remainder is 1 over x. The factor part, which is this part, becomes our y equals equation. So y equals that part creates our slant asymptote line. All right, so let's do the graphing of what we've got. We did not have a y-intercept. We did not have an x-intercept. We have a vertical asymptote of x equals 0. So we have an asymptote line coming right down the y-axis this time. We also found a slant asymptote. So let's go ahead and graph the line y equals 3x. Slope of 3. And we got that one in. All right, so now we have to build that table of points. I think I'll do it up here where I've got a little bit of room yet. Again, pick more if you need to. But we'll work with these. If we put negative 2 into our function, we're going to get negative 13 halves. Put in negative 1, we'll get out negative 4. Put in negative 0.5, negative 7 halves. 0.5 or a half, we get positive 7 halves. Put in a 1, we get a 4. Put in a 2, and we end up with 13 halves. So graphing these. My graph's not real big, so it's kind of hard to get all these points in there, but let's give it a try. At negative 2, negative 13 halves is 6.5, so I'm putting a point right down here. Then we've got negative 1 and negative 4, negative a half and negative 3 halves, 1 half, and it can't cross that line. So at this point, I know it's going to have to curl back. So the closer you would get to that 0 line, it would actually start heading you back down. 0.5, we have 3.5. And then at 1, we have 4. And 2, we have 6.5. If I could draw my line straighter, you would see that those are inside that asymptote line instead of outside. All right, so these are going to come in along here. And again, because it can't cross that asymptote, we can assume that it's going to head back up and out of that little section as well. So our graphs end up being, maybe I'll make them in green, kind of these little hook curves in each of them. Okay, now in our table here, we only went as far as negative 1/2. You know, if you picked negative 0.9 or negative 0.99, you would end up getting those other points that would curve you back out of there and you could see it better. All right. The only way to get better at these problems is to do a lot of them. A lot of sketching. Each of these was more or less the same kind of drill, so hopefully you got a good feel for how to get enough points to come up with a curve and to get those curved lines in there with those points, finding the asymptotes and things like that. So the exercises start on page 325. I can only encourage you to do a lot of them. All right, if you have questions, let's take care of them in class.